Yeah, so with questions like these, right, the one thing you're going to do is the following. Let me just show you quickly. Let me just show you. Yeah, so the one thing you're going to do here is the square. You don't have to worry too much about the square. The square should just keep you reminded that your whatever you end up with, you just multiply it by itself. So, for example, cos 180 plus something. You want to, if it cos plus anything, cos 180 plus something. If you think of 180 plus, right, from the cast diagram, you have C A, so CAST, right? CAST. So the idea with that is 180 plus. 180 plus comes in this quadrant. I see. And everything is, I mean, only 10 is a positive in this quadrant. So what you know already is that cos 180 plus x, this is going to give you minus cos x. But then the issue here is that if you have this thing here squared, right, it means that this will also be squared, of which negative cos squared is just going to give you a positive cos squared, because a negative times a negative gives you a plus, you see. That's why cos squared 180 plus x is just going to be positive cos squared x, you see, because this square here is just telling you that you're squaring your expression here. Does that make sense?
Yes, it does.
Yeah. So with what you call, with this, right, that's where we can start. We can start off by saying this is just going to be cos, let me write something a bit brighter, yellow. This is going to be cos squared x, and then plus. Okay, so here now we need to, what do we need to do? Yeah, so whatever you're going to do, right, you should not be afraid to just work it out somewhere on your answer sheet and then bring it back to your main question. So 10x minus 180. So there's a 10 there, x minus 180. One thing I always try and do is to swap these around first. Or rather, you can actually, let's see which method we can use. Yeah, I think swapping these around first may be a method that you can easily just remember. So if you swap those around first, right, what you can then do is in your cast diagram, you see when you work with the minus, you go clockwise first. So meaning you're gonna go 180 degrees, 180 degrees, and then the moment you minus, I mean the moment you this is minus 180 degrees, right? The moment you plus x, you go back. So meaning you end up in this quadrant here. You see it?
Yes.
Yeah. And in that quadrant, 10 is a positive. So that's why this is just gonna be 10x, like that. So this is gonna give you plus 10x. And then here now, the idea with anything that's like a big number, we said you always want to remove the highest multiple of 360. But funny enough, in this case, I mean, we could just remove it once actually, because in that case, it will actually maybe make your life a bit easier, because one by one, we're trying to simplify them. So here you have sine 720, right? So 720 is, you can remove, it's actually something you can just do. You can just remove what you may call 361. So this, you can write it as sine 360 minus x. And then 360 degrees minus x lands you in this quadrant, where only cos is a positive. So here you're gonna have negative sine x. So another way you
can
could have,
actually recall what you just said easily.
nice. So the fortunate thing is you could have also just jumped and said you're gonna remove the highest multiple of 360, meaning you're gonna remove 360 twice. So meaning you just end up with like sine negative x. So you see this is going to be a 0 minus x, which is just minus x. And the thing is, if you have sine with a negative angle in there, it's just negative sine x. You see two birds, two ways of doing the exact same thing. You see it?
I see it, but then like how would you explain just jumping from 720 directly to minus x? Oh, you're
Okay.
going twice. Never
Yeah.
mind, I figured it out.
Yeah. So the 7, remove 360 twice, you would have 0 minus x. And then this is just sine.
Yeah, see, this is
minus
what I
x.
mean when I say I'm tired. I'm sorry. Even the most basic of things are just bleh.
That was actually a good question. So it was a good question. It was necessary to ask. So we love to see it. But anyway, so now you see here where we see the sine 720 minus x. The big idea with what we are just talking about now is the fact that we need to, what is this? You want to put brackets here, otherwise you're going to mess things up. See? Sine x over there next to a cos x. And then here you're going to have cos 2x like that. And then with all this being done, right, you can just carry on. Okay, wait, we're trying to solve that. We're trying to show that the left side is equal to the right hand side, so we really don't need anything. So what we're gonna do here is cos squared x, right? Cos squared x. This is like 10x multiplied by this, multiplied by this. So already, because everything is being multiplied together, you can see here, you're gonna have a minus here now. Because this plus and the minus and the plus. You see, everything is gonna have a minus in front. And then the 10x, you can actually write it as sine x over cos x. And then the idea is, because these are not fractions, you can just write it on top over there.
Okay, I was wondering how we were gonna break that down. Okay.
Yeah. So that's the one thing you can always do. If you see that one thing is a fraction, just try and make everything else a fraction, so that you see how to work with it. So here now you have cos this one, cos squared x minus, okay, sine x times sine x is going to be sine squared x, and then times the cos there, and then cos x is down here. Cos x is like there. And then, so from here, we can see that we would need to at least try and carry on to do whatever we can to make sure that we end up with this. So things may seem like they're not looking up, but yeah, we can take out a cos as a common factor here. Yeah, let's take out a cos as a common factor. But if cos comes out, you're gonna have cos x here, and you're gonna have like cos x minus sine squared x, the whole thing over cos x. So this cancels this, but then at the same time, it still doesn't look like it's going to do what we want it to do. Unless we finesse it a bit. Like for example, you see this sine squared x there. We can change this using our what you call the square identity. Meaning this can change to.
Oh, there's so much square identity.
Yeah. So
Okay, go.
Yeah. So we have this minus is this minus there, and then this can change to 1 minus cos squared x. See, and then
Okay.
yeah, and then the final answer is just cos x multiplying side, that's like a minus 1, multiplying side, that's like a plus cos squared x. These are like terms. Come on, they're not like terms. I feel like I made a mistake somewhere.
I'm not gonna lie, it's kind of nice seeing you struggle a little bit.
Wow, that's funny. That is actually like haha funny. But anyways, let's see. So whatever is happening, it's all a matter of just going back to the beginning and trying to see where the issue is. So if I look nicely, oh yeah, there is the issue here. This is the
Oh, yeah.
mistake because these cannot mix. Oh, it's like a dumb mistake because you cannot put everything under the same denominator here. Doesn't make any sense at all. Because this is something to the left, something to the left, something to the right. It's two separate terms. If we want to put them under the same denominator, we have to get an LCD. So we can leave this the way it is, cos squared x. And then this one, we're going to have sine x times sine x is like sine squared x. And then cos x. The whole thing here over cos x. This one can cancel that one. And then you're just going to have cos squared x minus sine squared x. Which is then going to give you cos 2x. Because this is a double angle. If you check on your formula sheet, you'll see that you have the double angle of what you may call a double angle of cos there somewhere. You see it?
I
Yeah.
see it.
And then it boils out to be whatever it is that we have just laid out right now. Okay, so that's that for this question. Yeah, or you can obviously just say therefore left hand side is equal to the right hand side. Therefore, left hand side is equal to the right hand side. Like that. This is our
It's such a scam.